Solutions of homework problem. What are the problems? 2y in bracket a minus x dx plus z minus y square plus a square x square dy minus y dz is equal to 0. This is the second, third one, fourth, fifth, sixth, seventh, eighth. So the first example, 2y in bracket a minus x dx. So first show the given differential equation is integrable. So write x bar, then write curl, find x curl x bar, and then find x bar dot curl x bar. And if the given differential equation is not integrable, so the next example, second example is this. Compared with this, we have PQR, then X bar. They write curl X bar. This is curl X bar. Then X bar dot curl X bar is this dot product is 0, and therefore the given equation is integrable. And so how we can find the solution? These all homework examples are one variable, depend on the type, one variable separable. So divide by 1 plus z square x square plus y square. So we have this form. After dividing, we have y by x square plus y square dx minus x by x square plus y square dy, and 1 by 1 plus z square dz is equal to 0. So this is one variable separable, z variable is separated. So if you take x square plus y square as LCM, then y dx minus x dy, and this is the derivative of minus tan inverse y by x, tan inverse y by x, tan inverse x by y, tan inverse x by y. If you find the derivative of tan inverse x by y, then we have this, that y dx minus x divided by x square plus y square, and this is the tan inverse z. Integration of 1 by 1 plus z square is tan inverse z. So we have the answer, tan inverse x by y plus tan inverse z is equal to constant. The answer of this solution, this example. Okay. The next problem is this, z y dx minus zx dy minus y square dz is equal to. So compare with this, the p dx plus q dy plus r dz is equal to 0. Find p q r, and then x bar is this, curl x bar is this, and then x bar dot curl x bar is 0, and therefore we have the x bar dot curl x bar is this, and it is 0, and therefore the given differential equation is integrable. And how we can find its solution? Divide by x into y into z. So what do we have? Divided by x into y into z. So we have 1 by x dx plus 1 by y minus 1 by y dy minus y square y by hz, and then solve. It is one variable separable, and then solve it. So same example. This is y plus z dx dy plus dz is equal to 0, and then the given differential equation, write x bar, find curl x bar, then curl x bar dot x bar dot curl x bar, it is 0, and therefore the given differential equation is integrable. So dividing by y plus z, so we have this. This is one variable separable, the x variable is separated. So we have y plus z as LCM, so dy plus dz, and if we find the derivative of y plus z, it is dy plus dz. So f dash x divided by f will integrity. So integration of dx is x, and this is log y plus z, because by using rule integration f dash x divided by fx is log fx is equal to constant. So this is the final answer. Similarly, this is the example. Find x bar, then x bar dot curl x bar, and it is equal to 0, and therefore the given differential equation is integrable. So dividing by x into y square plus z square. So we have this x dx plus y by y square plus z square dy, z by y square plus z square dz is equal to 0. Then it is one variable separable again. X variable is separated, and then y square plus z square as LCM. If we differentiate y square plus z square, then it is 2y dy plus 2z dz. So adjust 2. So divide by 2 and multiply by 2 and integrate. So what we get? Integration of 1 by x is log x, 1/2 is constant, and integration of this 2y dy plus 2z dz divided by y square plus z square is log y square plus z square by z rule f dash x divided by fx rule. So it is log fx is equal to constant of integration, suppose c or c dash, and then log 1 by log x plus log y square plus z square raised to half by using rule m log a is log a raised to m, and then log a plus log b is log a into b. So x into y square plus z square raised to half is equal to new constant, suppose c1. So the next example is this. So again, find x bar dot curl x bar. It is not equal to 0, and therefore the given differential equation is not integrable. The number 6 example differential equation is not integrable. So then 7 number example, again find x bar dot curl x bar. It is not equal to 0, therefore it is not integrable. 8 number example, this is the example. So find x bar dot curl x bar. If it is equal to 0, then find its solution. So the given equation is this: z y square dx plus z x square dy minus x square y square dz is equal to 0, and then dividing by x square y square z, x square y square z. So we have 1 by x square dx, and here is 1 by y square dy, and here we have 1 by z dz by dividing by x square dividing by x square y square and z only, x square into y square into z. We have this, and this is one variable separable. Actually it is three variables separable. All the three variables are separated, so integrating. So 1 by x square integration is minus 1 by x, 1 by y square integration minus 1 by y, minus 1 by z integration log z is equal to constant is the answer of this problem. So all these are the problems of Homer. And then next type is homogeneous function. Homogeneous Pfaffian differential equation. Before that, we'll see the definition of homogeneous function. So when the function fxy is called homogeneous function, if it is expressed in the form x raised to n f of y by x, function of y by x. So if we express this function fxy as a in this form x raised to n f of y by x, function of y by x, then it is called a homogeneous function of two variables. So the Pfaffian differential equation pxyz dx plus qxyz dy plus rxyz dz is equal to 0 is called homogeneous Pfaffian differential equation if these pq are the homogeneous functions of same degree in x, y, z. So this is the definition of the homogeneous function in x and y. When we another definition of the function of homogeneous function is what? If the addition of indices of x, y, z in each term are same, then we say the differential. We say that the function is what? Homogeneous function. So if this PQR, when this PQR are the homogeneous function of same degree in x, y, z, if the function when the function pxyz is a homogeneous function, if the addition or the addition of indices or powers of x, y, z in each term is same, then we say the pxyz is a uh, homogeneous function of that degree. Suppose the example of homogeneous function, uh, this is x square z minus y cube. So this x square z minus y cube is a homogeneous function of degree 3 in xyz. Why? Because there are two terms. What are the two terms? X square z. So if you observe, the power of x is 2, power of y is 0, and z is 1. If you add these three powers of x, y, z, then we have the answer 3. Similarly, the another term is what? Y cube. That is the power of x is 0, power of y is 3, and power of z is 0. And if you add these three numbers, then we have the answer 3. So this is the homogeneous function of degree 3 in xyz. Similarly, this is the homogeneous 3xy square is the homogeneous function of degree 3. This x cube is the homogeneous function of degree 3. And so this differential equation that x square z minus y cube dx plus 3xy square dy plus x cube dz is equal to 0. Actually, this is the Pfaffian differential equation, and all these p, q, and r are the homogeneous function of same degree 3, and therefore this Pfaffian differential equation is called homogeneous Pfaffian differential equation. So when we say the pxyz plus qx dx plus qxyz dy plus rxyz dz is equal to 0, or p dx plus q dy plus r dz is equal to 0 is called a homogeneous Pfaffian differential equation of degree n. When we say it is a homogeneous function, homogeneous Pfaffian differential equation of degree n, if this p, q, r all are homogeneous function of same degree n. So this is the definition of homogeneous Pfaffian differential equation. P dx plus q dy plus r dz is equal to 0 is called homogeneous Pfaffian differential equation if p, q, r are homogeneous function of same degree. So the method to solve the homogeneous Pfaffian differential equation. The question is what? Explain the method to solve the homogeneous Pfaffian differential equation in three variables. So let pxyz dx plus qxyz dy plus rxyz dz is equal to 0 be a homogeneous Pfaffian differential equation of degree n in variable xyz. Obviously, means this p, q, and r are homogeneous functions of degree n. So we have to solve, we have to discuss the method to solve this homogeneous Pfaffian differential equation. So substitute y is equal to ux and z is equal to vx. So if the differential equation is of order is a homogeneous differential equation in two variable, then what is its form? Pxy dx plus qxy dy is equal to 0, and where p and q are the homogeneous function of the same degree. Okay, so and what is the method to solve the Pfaffian differential equation of two variable? Substitute just y is equal to vx. So here the substitution is what? Y is equal to ux and z is equal to vx. So what we have, dy is equal to u dx plus x du, the derivative, and dz is what? V dx plus x dv. And therefore the equation 1 becomes substitute y as ux, z as vx, and values of dy and dz as this. So we have px ux vx dx plus q x ux vx, and the value of dy as u dx plus x du plus r x ux vx, and the value of z as v dx plus x dv is equal to 0. So equation 1 becomes in this form. As pq are the homogeneous function of degree n, so cancel the x raised to n throughout we get. So these PQR are the homogeneous functions of degree n, and therefore we have x raised to n as a common factor in these three PQR. So if you cancel the x raised to n, then what we have? P as a function of 1, right, in bracket 1, u and v dx. That is this p1 uv dx plus q1 uv, and then u dx plus x du in the bracket, and r in bracket 1 comma u comma v x dx plus x dv is equal to 0. So if we observe this problem, suppose this is the problem that this is the Pfaffian differential equation, homogeneous Pfaffian differential equation of degree 3. If we substitute y is equal to ux and z is equal to vx in this example, what do we have? We have the transform form is what? X square vx, value of z as vx, minus y cube means u cube x cube dx plus 3x y square. What is y square? Is u square x square. Then value of dy as u dx plus x du plus x cube, and the value of z cube is what? The value of dz is what? V dx plus x dv is equal to 0. So if we cancel x cube, then what we have? So v minus u cube dx plus 3 u square in bracket this term, and this x cube get cancelled, v dx plus x dv is equal to 0. So if this is the homogeneous Pfaffian differential equation of degree 3, so we have x cube as a common factor, and if we cancel that common factor, we have this differential equation. Okay, so in the same manner here, the given differential equation is homogeneous differential equation of degree n, and that's why cancel the term x raised to n throughout. What do we have? P1 uv dx plus q1 uv u dx plus x du plus r1 uv v dx plus x dv. That is, this p q r are free from u v w x y z. So we have, after simplification, collect the coefficient of dx, collect the coefficient of du, and collect the coefficient of dv. So the coefficient of dx is what? P. Here is P, and another coefficient is u into q. This u into q, and another coefficient is what? R into v. Vr dx. These are the coefficient of dx, and the coefficient of du are what? The coefficient of du is what? X. X cube is only one coefficient of du, and the coefficient of dv is what? Xr is the coefficient of dv. So we have p in bracket plus uq plus vr dx plus x, take x as common from these two terms, so we have q du plus r dv is equal to 0, and then p plus uq plus vr dx, this is LHS, shift to RHS, what is now? Minus x q du plus r dv, and then shift this x to LHS, we have dx by x minus q du plus r dv divided by p uq plus vr, and this is the of the form dx by x plus q du plus r dv, that is, shift this term to LHS, we have this equation, r dv by p uq plus vr is equal to 0, and this is the differential equation in one variable separable form. This is the Pfaffian differential equation in one variable separable form. And what is the method to solve this one variable separable form? The previous in the previous topic, already the method is covered, that when the differential equation, Pfaffian differential equation, is one variable separable, then separate that variable and integrating, we have the solution, and use the tricks given in the chart. So hence, if it is integrable, then q du plus r dv divided by p plus uq plus vr is equal to 0 is exact differential equation. We know that if the one variable is if the Pfaffian differential equation is one variable separable, and if you separate that variable, then the remaining part is what? Is exact differential equation. But when, if the given differential Pfaffian differential equation is integrable, so suppose the given Pfaffian differential equation is integrable, then this part is what? Is exact differential equation. And if the given differential equation is exact, then there exists a function, suppose mu. Here the variables are u and v, so mu is the function of u and v, such that the complete derivative of mu is the part, this q du plus r dv divided by p plus uq plus vr, because this differential, actually this is the differential equation in u and v, and so this differential equation is exact differential equation. That's why we have the function, some function mu of u and v, such that its complete derivative is this part, this function q du plus this differential equation. And so if we write the value of this quantity as d mu in this equation number 2, then we have this dx by x, we have the equation dx by x plus this is d mu is equal to 0, and integrating we get what? 1 by x integration is log x plus d mu integration is mu is equal to constant, and this is the solution of that equation. After resubstituting, u is equal to y by x, because y is ux. So resubstitute as u as y by x and v as z by x, we get the general solution. So in this final answer, log x plus mu is equal to 0. Resubstitute u as y by x and v as z by x in this equation number 4. We get the required general solution of the given differential equation. So this is the method to solve the homogeneous Pfaffian differential equation. So the definition of homogeneous Pfaffian differential equation and the method to solve the homogeneous Pfaffian differential equation, both are important as far as the exam concerned. So the method, the question is what? Explain the method to solve the homogeneous Pfaffian differential equation in 3 variables. So the problem on this method, solve this problem. So this is the homogeneous Pfaffian differential equation. Why this is homogeneous Pfaffian differential equation? Because if you observe the coefficient of dx, that is p, coefficient of dy, that is q, and the coefficient of dz, that is r, then p, q, r, all three are homogeneous functions of same degree, and the degree of the pqr is what? 3, and therefore this p dx plus q dy plus r dz is equal to 0 is what? Is a homogeneous Pfaffian differential equation. Then first part of the solution of this example is what? Check x bar dot curl x bar is equal to 0, or show x bar dot curl x bar is 0, and then write the sentence that the given differential equation is integrable, and then the we have to solve this homogeneous Pfaffian differential equation. Then put y is equal to, what is the procedure? Follow this method, that put y is equal to ux and z is equal to vx. Then dy is u dx plus x dy, dz is v dx plus x dv. So we have this, after cancelling x cube, we have this, and so the same procedure, that uh, collect the coefficient of dx, collect the coefficient of du, collect the coefficient of dv, and then shift this, take x as common from these two functions, and then shift this term to RHS, and then shift the x to LHS. Dx by x is equal to, we have this form. Okay, same uh, as above, that dx by x minus q du plus r dv divided by this. So same procedure repeated for the example. We have this dx by x minus 3u square du plus dv divided by this, and this is the one variable separable. So this part is what? Is a derivative of some function, because the given differential equation is integrable, means this is the differential equation in u and v, and this equation is exact, means this is a derivative of some function. And what is that function? If we obtain the derivative of this denominator, then it is what? If we take 2 as common, so we have this 3e square du minus plus dv divided by uq plus v. And if you find the derivative of this denominator, then it is 3u square du plus dv, that is the numerator. And so after integration, we have integration of 1 by x is log x minus 1 half this, and the integration of this factor is what? Log of u cube plus 3, by using rule integration f dash x divided by fx plus constant of integration. And so shift this term to LHS, it become plus, then log a raised to m rule, and then we have log a plus log b is log a into b. We have this step is equal to new constant, suppose it is e raised to c1 is the RHS, and suppose e raised to c1 as c. And then lastly substitute u as y by x and v as z by x. So what do we get? X in bracket u cube means y cube by x cube plus v as z by x bracket raised to half is equal to constant, and this is the general solution of the given differential equation. Means once if you observe the given Pfaffian differential equation is homogeneous, then apply the procedure of homogeneous differential equation, that is substitute y is equal to ux and v is equal to y is equal to ux and z is equal to vx. Okay, so the next problem is of the same type, homogeneous Pfaffian differential equation. We will see remaining problem of the same method in the next lecture.